Okay, ladies and gentlemen, good day all. My name is Mukhtar Ali from the Department of Biochemistry ABU's area, and you are all welcome to my YouTube channel. And if this is the first time you are coming to my YouTube channel, please subscribe. So, in this video, we are going to look at the numerous factors that affect the enzymes catalyze reaction. So, there are the factors that affect the rates of reaction, and these factors include substrate concentration, enzymes concentration, product inhibition, temperature, pH, time, activators, and inhibitors. So let's start with the temperature. So generally, an increase in temperature increase the reaction or increase the kinetic energy of the reacting particles or of the reactants. So as you increase the temperature of the reacting particles, so generally the kinetic energy of the molecules or of the reactant particles will increase. Therefore, the collision will be increased between the reacting particles. Let's say in this case you have A as a substrate reacts with B, produce C and D, to produce C and D. So of course, because we are talking about enzymes activity, so there is an enzyme here which is E that converts these two substrates A and B into C and D. So what we are saying here is if you increase the temperature of the reactant system, the kinetic energy, that is the movement of the reactant particles, will increase. It will increase through elastic collisions. So they will be increased as the temperature increases, the kinetic energy will be increased due to increase in collision between the reactant particles, and as a result of that, a sufficient amount of energy will be provided in order for the reacting particles to convert into the product. So generally, the rates of this reaction increases with an increase. The rate of the reaction increases with an increase in temperature due to increase in a collision between the reactant particles. But of course, as you can see here, this is an optimum temperature. What is an optimum temperature? It means it's a temperature that is based for the enzyme's activity to occur, for the enzyme's catalysis to occur. So this is the maximum or optimum temperature. And of course, from this optimum temperature, then you realize that the rates of the reaction is decreasing. The rates of the reaction is decreasing from here to here. So the reason why the rate of the reaction is decreasing, because generally enzymes operate at their three-dimensional structure, that is in their tertiary and quaternary structure. So as the temperature increases above the optimum temperature, the integrity of the active site of these enzymes will start destabilizing, so that the substrate itself cannot be perfectly fits into the active site due to the denaturation of the enzymes. So generally, as the temperature increases above the optimum temperature, the enzymes will be denatured. And of course, once the enzymes is denatured, it means that the active sites of the enzymes cannot perfectly bind to the substrate. So as a result of that, due to the denaturation of the integrity or of the three-dimensional structure of the enzymes, the activity or the rate of the reaction will decreases. So generally from, let's say from zero, as you are increasing, the temperature, of the reacting system, the reaction or the rate of the reaction increases, as we can see here clearly. But when the temperature is optimum, that is the optimum temperature, that is the temperature that is maximally utilized by the enzymes to convert substrate to product. So as it increases above this optimal temperature, of course, the protein structure or the enzyme structure will tend to be denatured. So as a result of that denaturation, the active site of the enzymes will not be complementary to the substrate. So therefore, the rate of the reaction will start decreasing of the 0 point where the enzymes cannot catalyze any form of reaction. And of course, and that is for the temperature. And then the next thing after temperature, then we have pH. pH also, we have optimum pH. So generally, the rates of the reaction increases with an increase in pH, although it depends on the types of the enzymes. There are enzymes that work based at acidic pH, and there are enzymes that work based at basic pH. So if you have such conditions, so generally as you are increasing the pH, the rate of the reaction also tends to increase. So as the rate of the reaction increases with an increase in pH, it will also come to optimum pH, where the enzymes work best. So if higher or slash lower hydrogen ion, that is in acids, or OH in alkaline base, can interfere enzyme structure. So it depends on the concentration of it depends on the pH and the types of the enzymes. Some enzymes work based at acidic pH, while some enzymes work based at an alkaline pH, that is above 7 points, and some below 0, and some of course work at a neutral pH. So generally an increase in pH, for example, if it is alkaline, of course the pH of an alkali is generally above 7. So when the pH of an alkaline medium where the enzymes work start decreasing, it means that it will be changing from an alkaline environment going back to the acidic environment. So as a result of that, the pH can interfere with the enzyme structure. And of course, if the enzymes work at an acidic pH and it now increases from acidic to basic, so it means that the structure of the enzymes will also be affected. So as a result of that, the activity of the enzymes will be decreased. So that is what happened. So as the pH increases or decreases, that leads to interfere with the enzyme structure, and it affects the activity of the enzymes. So but generally, as you increase the pH, the activity of the enzymes increases up to its optimum pH. But as the optimum pH is rendered whether by decreasing or increasing, which leads to interference of the enzyme structure, then the activity will decrease. And then the next thing is enzymes concentration. So as you increase the concentration, that is the amount of the enzymes, you are also increasing the rate of the reaction. So generally, an increase in enzymes concentration leads to increase in the rate of the reaction, because as you are increasing the concentration of the enzymes, it means that at the same time you are increasing the amount of the binding sites for the substrate. That is, the amount of the active sites are also increasing, so that more of the substrate can be bind and converted to products. So we have a steady state if the substrates are available. So generally, generally, as if we can now see this from here to here, it tells us that as you increase the concentration of the enzymes, and of course the rate of the reaction will increase. So that's because there are more active site of the enzymes that are available for binding with the substrates. But if the substrate is limited, that's when it means that when we say the substrate is limited, that means that it's a situation where you have more of the active sites than the substrates, and all the substrates are now bind to the active sites for the catalysis, and no more other free substrate. And of course, the rate of the reaction will start declining. It will start declining. So it means that for the reactions to proceed simultaneously without or to increase continuously, it means that both the concentration of the enzymes and the substrate must be increased at the same time. And then the next thing is substrate concentration. So substrate concentration also increases rate of the reaction. So it means that the more you increase the substrates of the reaction, the more the substrate will bind to the active site of the enzymes. And of course, the rate of the reaction, that is the speed of the reaction, will also increase. But if you now reach to a point where all the enzymes or all the active site of the enzymes are used off, some substrate remain free, that there is no available active sites binds, so it means that it will now reach to a saturation state. That is where we have this parabolic shape graph. So you see here, as you increase the substrate concentration, the rate of the reaction increases. But if all the active site of the enzymes available is being saturated with the substrates, so what will happen? To now reach a flattened where there is no increase or decrease of the reaction, but at the starting point it increases. But when it reaches this state, it means that all the active site of the enzymes is being filled off with the substrate. That is where we have maximum velocity. This is where we have maximum velocity, that is V max. It means that the enzymes reach, it is V max. So that is actually for this four factors. Temperature increases the rate of the reaction, but further increase will lead to the nature of the enzymes, and also enzymes have optimum pH depending on the type of the enzymes and the medium that the enzymes require. So if an increase or change in the pH alter or interfere with the enzyme structure, and of course the activity of the enzymes will be decreased. And of course, generally an increase in pH leads to increase in enzymes reaction, which is thereby increasing the rate of the reaction. So this is for enzyme, or for the four factors that are affecting the rate of the reaction. So now the next thing that we are going to look at is, of course, the effect of the substrate concentration, as we said. So the shape of the curve that relates activity to substrate concentration is hyperbolic. So this is hyperbolic shape. And of course, this is the first order reaction. This is the first order reaction. It means that an increase in the substrates have effects on the increase in the concentration, so have effects on the increase in the rate of the reaction. So we have first order. So from here to here, from here to here, we have first order. It means that an increase in the rate of the reaction is dependent on the increase in the concentration of the substrate, that is the reactant. And of course, this is a zero order reaction. When we say zero order reaction, it means that at this point, the rate of the reaction doesn't have any effect. It doesn't have any effect on the rate of the reaction because all the substrate is occupied or have occupied the active site of the enzyme. So that is why it's zero order. So the rate of the reaction is independent on the concentration of the substrate. So like for example here, if you can look at points A and B, this is point A, this is our point A, and this is our point B. So if you can see point A to B, there is an increase or decrease in substrates. There is an increasing or decreasing concentration of the substrate. Thereby, will increase or decrease the number of enzyme substrate complex with a corresponding change in velocity, that is initial velocity. So the rate of the reaction is substrate dependent, which is first order reaction. Then at point C, essentially all the enzymes is present at the enzyme substrate complex stage. It means that the enzymes and substrates are being formed together and there is no any free enzymes. So it means that all the enzymes at point C is present at enzyme substrate complex. Since no free enzymes remains available for forming enzyme substrate complex, a further increase in substrate concentration cannot increase the rate of the reaction. So reaction rate therefore becomes independent of substrate concentration, and that is zero order reaction. So the zero order reaction, it's points where the enzymes is completely filled with the substrate, and increasing the concentration of the substrate doesn't have any effect on the rate of the reaction. So we have Km and it is significant. So Maclaurin's constant, which is Km, Maclaurin's melting constant Km is the substrate at which the initial velocity half the maximum velocity. Of course, we know that, as I said, when the enzymes is completely filled with the substrates, and at that point you have all the enzymes at a stage of enzyme substrate complex. So at that stage, it means that you have V max. We have B max. At that stage, we have B max. So as I was saying, it means that when you have enzymes substrate complex, it means that there is no free enzymes at this stage. It means no free enzymes. So all the enzymes at this stage is being utilized for the formation of enzyme substrate complex. Therefore, it means that the enzymes is V max. It is maximum velocity. And of course, there is a relationship between Km and V max. There is a relationship between Km and V max. And the relationship is that Km is equal to half V max. So Km is half V max. So it means that when you have your enzymes starting from here, then it now reaches to this plateau stage where all the enzymes and the substrate form enzyme substrate complex. So no free enzymes. So it means that the rate of the reaction it is V max, that is, it is maximum velocity. And the relationship between Km and V max is half max. So thus, the Km has the dimension of substrate concentration So it is specific and constant. So this Km specific and it is constant for a given enzymes under defined conditions of time, temperature, and pH. So there are enzymes, because we have different enzymes, we can have glucokinase and hexokinase. Although there are isozymes, they are enzymes that catalyze the same substrates, but they have different Km under defined conditions of time, temperature, and pH. So even within isozymes, you can have isozymes with different Km values. And of course, the enzymes that catalyze different types of reaction may have different Km value. And these Km values determine the affinity of enzymes for its substrate. And the lesser the Km for the affinity so it means that what this means is that the Km is used to determine the affinity of the enzymes toward its substrate. And the lower the Km value, the lower the Km, the higher the affinity of the enzymes. It means that if you now have enzymes A and enzymes B, enzymes A and enzymes B, and enzymes A have low Km, while enzymes B have higher Km. So what does that mean? It means that the enzymes with lower Km have affinity or have the ability to bind to the substrate more than the one with the higher Km value. So Km value, it helps in determining the true substrate for the enzymes. So you can use this Km value to determine the best substrate for a particular enzymes. So that is for the Km value, and it is significant. So you can use it. In fact, this Km value is used in drug discovery by knowing the Km for a particular inhibitors. It will give us an idea whether the drugs will be the goods or the targets of a particular disease of interest. So now the next factors that affect the rate of the reaction is the effect of product concentration. So generally in a particular pathway, in a given pathway, like for example, the products of a particular pathway can serve as an inhibitor of the starting enzymes of that particular pathway. Like for example, this is a pathway. The first enzyme is enzymes 1, so we have enzymes 2, enzymes 3, and we have the product. So but in this case, the product of this reaction now inhibits the first enzymes of that reaction, and the process of this is called feedback inhibition. Like for example, generally like in glycolysis, we have what you call glycolysis. So in glycolysis, we have glucose, and the glucose is converted through a series of like about 10 reactions. A pyruvate is generated. A pyruvate is generated, and of course the first enzymes for glycolysis is hexokinase. So if the pyruvate, which is the end product of glycolysis, is accumulated or is produced in high amount, so these products will now go back and inhibit the first enzymes of this pathway, that is the first enzymes of glycolysis. So this type of inhibition is called feedback inhibition. So when the enzymes of a particular pathway is inhibited by the product or by the final product of that pathway, so the process of this inhibition is called feedback inhibition. So under certain conditions, the reverse reaction may be favored. forming back the substrate. So that is why whenever you have this kind of inhibition, that is feedback inhibition, like in glycolysis, so it means that the backward reaction, that is the reverse reaction, will be favored. So that is why whenever you have feedback inhibition in glycolysis, so it means that there will be gluconeogenesis. Gluconeogenesis. So when we said gluconeogenesis, it means gluco means glucose, gluco means glucose, and then neo means new, and genesis, of course, is synthesis, So it means that in the feedback inhibition here, glucose produces pyruvate, and the pyruvate is accumulated and it now inhibits the enzyme. So it means that the substrate here, which is pyruvate, will now go back and synthesize glucose. So the process of doing that is called gluconeogenesis, and that is a typical example of feedback inhibition. So the next time is the effect of activators and coenzymes. So the activity of certain enzymes is greatly dependent on metal activators and coenzymes. So vitamins, most of the vitamins, they act as a coenzymes in a variety of reactions. So like for example, from the previous, we talk about glycolysis. So like for example, in this glycolysis, the first reaction in glycolysis is the conversion of glucose to glucose 6-phosphates, and of course in this reaction enzymes called hexokinase is required, and ATP is utilized, and glucose 6-phosphate and ADP are generated. But this enzyme hexokinase require a cofactor. It requires a metal ions. It requires a metal ions magnesium ion, magnesium 2+. So this is an example of cofactors that is required to make this hexokinase active for it to convert glucose to glucose 6-phosphate. The process of doing this is the effect of activators and the coenzymes. And of course, there are some reactions. And of course, these types of reaction is the types of reaction that have effect on both the activators and the coenzymes. And furthermore, we can have some reaction that require coenzymes, like for example, we have an enzyme called glyceraldehyde 3-phosphate dehydrogenase in glycolysis. So it requires coenzyme, and the coenzyme is NAD plus nicotinamide adenine dinucleotide. So this is the examples of the coenzymes that is required for these types of reactions. So they are very essential. They are factors that affect the rate of the reaction, and if there is no these cofactors and coenzymes, the reaction may likely not to occur. So now the next thing is the effect of modulators and inhibitors. So enzymes activity is generally reduced in the presence of an inhibitor. And when you say inhibitors, it means that they are the molecules that usually bind to the enzymes, and the bend will decrease the activity of the enzymes. So generally, as there is an increase, if there is an increase in inhibitor, there will be decrease in enzyme activity. And there is also modifier, that is positive modifiers, which are called activators. So what they do, they increase the rate of the reaction. So inhibitors and activators. So positive modifier are activators. So they generally increase the rate of the reaction. And then the next thing is effect of time. So the longer an enzyme is incubated with its substrate, the greater the amount of the product that will be formed. However, the rate of formation of product is not a simple linear function of the time of incubation. So all proteins suffer denaturation and hence loss of catalytic activities with time. So time is important, but the incubation time is important because there are some points that when you allow your reacting system to stay long, maybe with an increase in temperature, there is a likelihood that the proteins will suffer denaturation. And once that happens, it means that there will be no activity. So this is an example of enzymes catalyze reaction under completion in an optimum time. So you look at it as an optimum time. So if you can now clearly see this, you can see that with the time, or with an increase in time, there is an increase in product formation. But you see at this point, it starts going down. So that is, it means that if you now allow it to continue like this, then it will affect the reaction. So variations of time affect the rates of enzymes catalyze reactions. So ladies and gentlemen, this is the end of the today class, which is the factors that affect the rate of the chemical reaction. And if this is the first time you are coming to my YouTube channel, please subscribe for more video content. Thank you for listening.